Sir, is any professors from Sriram College is joined? Nagarajan sir is there?
Yes, Gokul.
Okay, sir. Professors from Sriram College, can you unmute, sir, so that I can make you co-host? Sir, Pandian sir, welcome, sir.
Good afternoon, Engineer Gogol.
Yes, sir. Yes, sir.
Am
I think
audible?
I made you co-host, sir.
Okay.
You are audible, sir. You are audible. Perfectly audible.
Okay.
Good afternoon, Mr. Pandian. This is Nagarajan.
Good afternoon, sir. Good afternoon, sir.
How are you?
Fine, sir. Thank you.
Today's topic is very apt.
Yes, sir.
I am Nagarajan, Chennai Regional Center Chairman, and
Okay, sir.
I was with the oil and gas industry for almost last maybe 20 years.
Okay, sir.
I was with Technip Jakarta. John Brown, you might be knowing because we have worked on ONGC projects, lot of ONGC projects.
Yes, sir.
Earlier I was with Engineers India Delhi. That time we were more with the Indian Oil. I have visited almost all your refineries.
Yes, sir. I think I have attended your webinar, sir. I think maybe 2 months back.
Oh, okay. Through ICH or some other?
I think yes. I think IEI. Institute of Engineers, True State Center. I think. Actually, I am in marketing division. So mostly, I will my experiences in bottling plant.
Oil movement and storage.
Yes, sir.
Pandian sir, you can check it up. You can share your screen and see, sir.
Okay.
Also your video also.
Okay, sir.
Maybe another 5 minutes we'll start, sir.
Okay. Is it okay, Engineer Google?
Yes, sir. Perfectly. I think we can see that. And video, if you want to play it also, you can just trial it, sir.
Okay, sir. For that, I got to stop the screen. This PPT or simultaneously I can play.
Yeah, I think you can minimize and you can check it out, sir. I am also not knowing.
Okay. Is it okay, Engineer Google?
Yes, it is playing. Volume you can just keep and see, sir. It's good. It is playing, sir.
Volume is full only.
Full only, sir. But okay, we could not able to hear.
Okay. What you will do?
No, your system volume and both volumes are okay, sir.
I will. It is in 100 only.
Okay.
I will do one thing. Otherwise, I will make any speaker.
Yeah.
I will check.
Yes, sir. So welcome Dr. Nagarajan sir, HOD Sriram Engineering College.
Good morning, sir.
Okay,
Good
sir.
afternoon, Mr. Nagarajan. I think
Good afternoon, sir.
we had a memorable function in your college.
It's a symposium event, sir. You come here for a function. Nice meeting you again, sir.
Yeah, see. Nice to have you again. Thank you.
Thank you, sir. Can we start the session, sir?
Yeah, no, our speaker is checking.
Okay, sir.
2 minutes.
Okay, sir.
There is, like in Zoom, the speaker how to get back, sir? Like, sir is having 100 in both the voices, but we could not able to hear here.
Yeah, video voice is not coming.
பாண்டியன் சார் பார்க்க முடிஞ்சதா இல்ல பரவாயில்லையா சார்?
Gogol sir.
சொல்லுங்க சார். Yes sir.
Any improvement?
We could not able to hear, sir.
What will do?
No issues. I think we can start. Maybe
No, actually, this is only we can see the what is the overview of on a refinery.
Yes sir. அது நீங்களே அப்படியே கொஞ்சம் சொல்லலாம்னு நினைக்கிறேன். அது போக சொல்ல லைட்டா.
என்னுடைய வாய்ஸ் ஓகேவா?
ஃபைன் சார். அப்ப ஓகே சார். நீங்க அப்படியே இத ஸ்டாப் பண்ணிடலாம்னு நினைக்கிறேன். நீங்க பிரசன்டேஷன்
ஓகே
அத ஸ்டார்ட் பண்ணிடலாம். எஸ் சார்.
ஓகே.
Google sir, can we start, sir?
Yes sir.
Yeah, okay, sir.
Maybe you can ask your professors to start, sir. So Dr. Nagarajan sir.
Good
think-
Yeah, starting, sir.
afternoon to all the faculty members and students. Can you hear me? Good afternoon, everyone. This
Yes, ma'am.
online webinar on topic opportunities and challenges of engineers in oil industry by the Department of Chemical Engineering, Sriram Engineering College, in association with IACHE, Chennai Regional Center. Now I invite Dr. L. Nagarajan, Head of the Department of Chemical Engineering, to deliver the welcome address and to speak about IACHE student chapter of Sriram Engineering College.
Good afternoon to one and all. It is not of whom who wills, not of whom who runs, but God who shows his mercy. So I welcome you all for the webinar at Sriram Engineering College in association with IACHE Chennai Regional Center. It takes immense pleasure to thank Mr. Gokul, scientist, ISRO, Honorary Secretary, IACHE, and for arranging Dr. Angin for the webinar and organizing this event in an orderly manner. I thank the management and trustees of Sriram Engineering College supporting us in all the developmental activities. I welcome students of SRP Sriram Engineering College and other engineering college students. Can you able to hear me? I welcome students of Sriram Engineering College and other engineering college students for attending this webinar, and I promise that it could be definitely be a wonderful knowledge sharing session. The student chapter was inaugurated in Sriram Engineering College in the year of 2018. So with the assistance of student chapter, we have conducted 2 symposiums in the year 2018 and 2019. They have arranged guest lectures and summer internship programs for students. Even during this pandemic period, they support us by conducting online internship to our students. We like to continue this in future. So thank you, Mr. Gokul, because he is the backbone for pastors supporting all these activities. Once again, welcome you all for this wonderful webinar. Thank you.
Thank you, sir. This
Ma'am, I think your voice is breaking, ma'am. Ma'am, I think your voice is completely breaking. Can you recheck, ma'am, again? Yeah.
Am I audible now? Is the voice okay?
Now it is okay. Yeah.
Okay. And Mr. D. Gokul, ISRO scientist and honorary secretary of IICHE CRC.
What you said, I can't get you. I think you can first invite our Nagarajan sir, then you can invite me.
Yes, sir. Actually, she invited Mr. Nagarajan
Okay,
sir and yourself, sir.
Then
So
I would
first,
like
Mr.
then I
Nagarajan
will invite
can
Mr.
give a few words.
Nagarajan Natarajan sir to deliver his speech.
Good afternoon, all the participants, and Dr. Nagarajan, HOD, Chemical Engineering Department, Sriram Engineering College, and the other organizing professors, the student chapter members, and our honorary secretary, Mr. D. Gokul. And most importantly, we extend a warm welcome to Dr. G. Pandian, Senior Manager with Indian Oil Corporation Limited, Chennai Marketing Division. And we welcome you, sir, and we would like to hear your topic, which is very apt today, the challenges in the oil industry for the engineers. And
Thank you, sir.
hope this will definitely give an exposure to the students, because they have to have a practical side of their career, because before starting the career, if they know the industry and the various aspects of the industry, it will really help them to understand and go forward to take up their employment with such big companies. So with that, I thank Dr. Nagarajan of Sriram Engineering College for providing us this opportunity to bring a guest lecture from a very experienced person from one of the major public sector organizations in India. Indian Oil has, I think, more than 12 refineries. Dr. Pandian can correct me. My number
Yes, sir.
may
Yes,
be
sir.
old.
11, sir. 11.
Almost 11 major refineries. And I'm happy to inform you that during my early part of the career with Engineers India Limited, I had been to all their refineries, especially when I joined in 1980, the Mathura refinery was under construction. So I had a good opportunity to see the crude and vacuum units and fluid catalytic cracking unit also. So under construction, it is a very good opportunity for engineers to see all the equipment which are in the open condition.
Yes,
You go to a operating plant, you will not be able to see anything. All the full process will be going on. You can only see the equipments in the closed operating conditions. So
Very nice, sir. Very
I
nice.
think it is better to organize some industry visits to students once the pandemic situation ends. I think we will request the help from Indian Oil Corporation to allow the students to have a view of the refinery, which gives an exposure to them, what they study in books and what is actually being in the reality. That's a very good exposure. So with that, maybe Gokul, you want to add something?
Yes, sir. Yes, sir. You can complete it, sir.
So okay, so once again, thanks to all the organizers, and welcome to all the participants and students. Please keep your pads and pens ready, and make note of the important points as being presented. And also, you can note down your questions. And at the end of the session, there will be a opportunity given to all the students, so they can raise their questions and get the answers from our chief guest. So with that, I request Dr. Pandian to start his presentation. Welcome you, sir. Thank you.
Thank you, sir. Thank you. Thank you very much, sir.
Yes,
Good
ma'am.
afternoon.
Soumya, ma'am. Yeah, yeah. So one second. Yeah, Soumya, ma'am, can you hear us?
Yes, sir.
Yes, ma'am. You can proceed.
Okay. I welcome Dr. S. Sivamani to deliver the keynote address about the speaker.
Very good afternoon to one and all present. Respected Dr. S.R. Kannan, the Principal, Sri Ram Engineering College. Respected Dr. L. Nagarajan, the Head of the Department Chemical Engineering, Sri Ram Engineering College. Respected Dr. D. Gokul, Honorary Secretary, Indian Institute of Chemical Engineers, Chennai Regional Center, and ISRO scientist. Today's distinguished guest, respected Dr. G. Pandian, Senior Manager, Indian Oil Corporation, Chennai. And dear faculties and my dear students, I welcome you all to this interesting online webinar. It is my immense pleasure to introduce today's online webinar's eminent speaker, Dr. G. Pandian, Senior Manager IOCL Chennai. With this brief background, Dr. G. Pandian has completed BE Electrical and Electronics Engineering at Anna University, Chennai, and Master of Science Electronics and Control at Birla Institute of Technology and Science, Pilani, Rajasthan, and PhD in Electrical Engineering at Bharat University, Chennai. And also, Dr. G. Pandian has completed MBA at IGNOU, Delhi. Since 34 years, Dr. G. Pandian has been serving in Indian Oil Corporation Limited, Chennai. And Dr. G. Pandian had been holding various professional institutions membership, such as Institution of Engineers, Kolkata, and Institutions of Electrical and Electronics Engineers, IEEE, USA, and the National Safety Council, Mumbai, etc. And Dr. G. Pandian has published 7 international journals so far in induction motor drive field. He has been involved various project execution and management and operation and maintenance since 1985 in Indian Oil Corporation Limited, Chennai. Bottling plant won the British Safety Council Award for year 2017 and 2018. It is awarded for outstanding safety bottling operation, with strictly following the standard operation procedure continuously and maintaining better safety system in the plant at par with the international standards. I welcome you all in this webinar. Thank you.
Thank you very
Thank
much,
you, sir. Thank you for the brief introduction about the speaker. Thank you, sir. Now I cordially invite Dr. G. Pandian, Senior Manager, Indian Oil Corporation Limited, Chennai, to start with the session.
Thank you very much. Good afternoon to everybody. Mr. Nagarajan, Mr. Kogan of Indian Institute of Chemical Engineers, and the faculty from Sri Ram Engineering College. I would like to thank organizers for giving me this opportunity. The types of industries. Classification based on the size of the industries. We can classify it as small scale industries, medium scale industries, large scale industries.
Sir,
So based on the, yes.
Sir, your PPT is not visible, sir.
One second.
Now it is shared, sir. Yeah, you can make it PowerPoint mode, sir.
Okay.
Yes, sir. Perfect, sir. Yeah. Okay, sir.
So various types of industries. So based on the size, we can classify it as small scale industry, medium scale industry, large scale industry. So based on the product classification, heavy engineering industry, manufacturing industry, steel plant, cement plant, and so on. See, classification based on the process. So it is called as a process industries. Petrochemical industry, petroleum refinery, fertilizers industry, pharmaceutical industry, dairy milk product industry, sugar industry, automobile tire industry, bottling industries. See, these are the based on the classifications. So type of oil industries. How we can classify based on the process. Oil exploration. It is called onshore and offshore oil exploration. Petroleum refinery. Petroleum transportation. It's called pipeline transportation. Petroleum storage terminals. Lube oil blending plants. LPG storage terminals. LPG bottling plant. LNG storage terminals. These all are coming under the oil and gas industries. See, this is the layout of one oil industry. Onshore, offshore oil exploration. It is the schematic diagram. Then pipeline. Then oil refinery. Then downstream storage tanks. So crude oil is explored from the oil wells, either from onshore or offshore. It is transported to the refinery. In the refinery, the crude oil is refined as a various products: LPG, naphtha, petrol, diesel, aerofuel, and so on. So you can see the layout, how the crude oil is exploring and transporting to the oil industry, and again it is transported to the pipeline to the major storage terminals. So this is the another diagram. So offshore oil well. So it is installed in a sea. The upstream is the exploration and production. Midstream is the transportation of the crude oil to the refineries. The downstream is the refineries, where the refinery process crude oil to the produce different products, petrochemical plants, polymers, plastic, and other products. So this is called the downstream of the oil industry. The refineries in India, see, this figure is located at the various refineries in India. So we can able to see the Panipat, Madura, Pongaigan, Baroni, Guwahati, Big Boy, Paradeep, Haldia. Then our south, Manali, CPCL. Then another one is Kaveri Basin, Narimana. It belongs to Indian Oil Corporation and other company, private company, as well as the Bharat Petroleum and Hindustan Petroleum. So they are having the refinery in Mumbai, in Kochi. So apart from that, private companies like refineries, you can able to see the locations. So these are all the refineries in India. I think it is totally 24 refineries, all put together. What is the capacity? See, Digboy is 0.65 MMTPA and Guwahati 1 MMTPA, Baroni 6, Gujarat 13.7 MMTPA. See, these are the capacity of the refineries, each refineries. So our Indian Oil Corporation is sharing almost 32% with the total production. So CPCL also is one of our group company of Indian Oil Corporation. So including CPCL, we are sharing 32%, 80.2 MMTPA. So these are the other refineries in India. So Jamnagar Reliance, then Nayara Energy Refineries, Vadinar. See, compared to this private refineries, so our refinery is very old, more than 30 years old. So these private refineries are very, very, very new. That's why its capacity is a little bit very high compared to our government refineries. IOC, HPC, BPC. These are the other refineries. Manali refinery. That is Manali refinery CPCL. Its capacity is 10.5 MMTPA. In Visakhapatnam, Hindustan SPCL, 8.3 MMTPA. Nagapatnam CPCL is a very, very small refinery. So these are all the refineries in India and their capacities. So raw material for the refinery is crude oil. So crude oil combustion is complex mixture of very long chain hydrocarbon molecules. Broad characterization of crude oil is based on the most prevalent form of hydrocarbon, that is paraffins, naphtha, and aromatics. Small quantities of sulfur and nitrogen, oxygen are also present. Traces of heavy metals like nickel, indium, arsenic, etc. decide the quality of the refined products. See, based on the crude oil quality, the quality of product is differs. These are the various different crude from the Bombay High, Pony Light, Arab Light, Kuwait. See, these various crude quality, percentage of sulfur is varying. This is overview of the refinery. So you can able to see a huge area. Occupies it's a small city. It consists of structures, distillation unit, storage tank, gas storage, spares. So you can, and so on. The separator or vessel designate the pressure vessels used for the separating the well fluids or process fluids in gaseous and liquid components. Separating vessels may be referred to the following ways: oil and gas separator, knockout vessels, scrubber, knockout drums, knockout trap, water knockout, or liquid knockout. So flash vessels, expansion vessels, drain vessels. So separators work on the principle and the components having different densities, which allows them to stratify when moving slowly with the gas on top, water at the bottom, and oil in the middle. Any solids such as sand will also settle in the bottom of the separator. So it consists of many pressure vessels, separators, condensers. So based on the temperatures, the crude oils become a vaporization, and it is at various temperatures, it will cool, it convert the products. In a gaseous form, is LPG, then gasolines like naphtha, petrol, then again diesel, superior kerosene, and so on. So type of chemical engineering operation, unit operation, chemical changes. So momentum transfers, so transfer of fluids, so pressure differential. Driving force is the concentration of differential. Heat transfer, transfer of energy, mass transfers, transfer of components. So unit process, chemical changes. All reactions and synthesis, catalytic and non-catalytic. So this is the chemical. So refinery, it is fully chemical process. So right from the crude oil, it is converted into the LPG, naphtha, petrol, diesel, ATF, and residues. So process plant operations, feed preparation, reaction, energy recovery, product separations, support system, utilities, offsite, and logistics. So what are the petroleum products? So refinery fuel gas, liquefied petroleum gas, solvent, naphtha, gasoline, kerosene, jet fuel or gas turbine fuel, diesel fuel, fuel oil, residual fuel oil, lubricating oil, asphalt, petroleum coke. See, these are the products from the refinery. The refinery process, crude distillation, catalytic naphtha reforming, fluidized catalytic cracking, hydroprocessing, residue upgradation. So this is the various distillation process in a refinery. So atmospheric distillation, first step in a refinery of crude oil. Crude oil is fractioned into sharp cuts in an atmospheric distillation column. These cuts are generally unstabilized naphtha, kerosene, and ATF, light gas oil, heavy oil gas. Bottom of the crude column is known as reduced crude oil. A single or multiple columns would be used for fractionation. Crude is first preheated in a preheat exchangers, heaters, and then pumped to the crude column. So this is schematic diagram of a food distillation unit. So crude oil is heated through the steam, high temperature steam, and it is given to the distillation column where the based on the temperature products are separated. You could see the distillation column. This gas, LPG, naphtha, so up to 170 degree. Kerosene up to 270 degree. Diesel up to 360 degree. So this is the crude distillation column. Then more than 360 degree is a heavy ends. See, based on the application, it is domestic industrial heating transport application. This LPG is used for this domestic industrial heating transportation, and petrol is used for the transportation. Then ATF is used for the aviation fueling, and also this is for heating and lighting. Then HST, diesel, used for the transportation and power generation. Then furnace oil and LSHS oil is used for the industrial purpose, furnace and power plant. So these are the product wise the application. This is the crude oil to the product. Light distillate, middle distillate, then heavy ends. How the crude oil is converted into the various petroleum products. So this is the unit operation. There are 3 stages of refining. Crude oil is to be processed. 3 major type of operation are performed in a refinery. The crude oil into the finished product. It is separation, conversion, and treating.
Sir, hello.
Google, I could not. It is not changing. 1 second.
Okay, okay. But I think somebody scribbling, students who are scribbling, I think will be removed from this Zoom.
Okay.
Otherwise, you can just leave this group. We found out something in the history. That's all. Severe action should be taken against you through your HOD. This is not the way to sit here.
If anybody not interested, you can leave. Don't disturb the session.
I will check up who has done in the history.
Yeah, no,
We have to report them. Report it to their college. If these engineers do all this kind of unprofessional ethics, we don't.
Facing some problem too. It is not, slide is not changing. I'll check.
Yes, sir. Maybe நீங்க திருப்பி ஸ்டார்ட் ஸ்கிரீன் பண்ணலாம்னு நினைக்கிறேன் சார். வெளியில வந்துட்டு.
என்ன பண்ணலாம் கூகுள் சேஞ்ச் ஆக மாட்டேங்குது.
இல்ல நீங்க பவர் பாயிண்ட்க்கு மெயின் பவர் பாயிண்ட் போய் பாருங்க சார். அங்க ஸ்லைட் ஷோல இருந்து ரிமூவ் பண்ணுங்க.
ஓகே, ஒன் செகண்ட். அத ஸ்டாப் பண்ணிட்டேன். ஸ்டாப் பண்ணி மறுபடியும் அகைன் ஷேர் பண்றேன்.
இல்ல பிபிடி ஓபன் பண்ணி பாருங்க. ஏன்னா சம்டைம் எனேபிள் எடிட்டிங்னால கூட அப்படியே ஹேங் ஆகும். இது ஸ்லைட் ஷோல இருந்து மெயின் பிபிடிக்கு போய் பாருங்க சார்.
ஒன் செகண்ட். Okay. Is it changing? Google?
You have
Google?
to share it.
It's not changing.
No, we are not seeing your PPT.
Okay, one second.
Yeah. இப்போ பாருங்க சார், நெக்ஸ்ட் ஸ்லைட் போய் பாருங்க.
Okay, okay.
And now it is coming. And now it is coming, sir.
Okay. So okay. Optimum refinery operation. Each refinery has its own unique processing scheme, which is determined by the process equipment available, crude oil characteristics, operating cost, product demand. See, these are all the various factors. Based on that, we can improve the optimum operation of the refinery. The optimum flow pattern for any refinery is dictated by the economic consideration, and no two refineries are identical in their operations. So again, this is the schematic diagram of a refinery. Refinery storage point and transportation through the trucks. So what are all the major equipment in a refinery? So main equipment is the boiler house, power generation plant, refinery process, distillation units, electrical substations, process instrumentation and control, heat exchangers and cooling towers, pumps and compressors, pipelines and control valves, water treatment plant, larger product storage tanks. So in any refinery, as I told, from crude oil, so we can convert the petroleum products as a diesel, petrol, LPG, naphtha, ATF. So these products are stored, so each and every distillation unit through pipelines. The products are stored in a storage tanks. So these are all the auxiliary equipments. So very important. So boiler. So how we can heat the crude oil? Steam. So from boiler, steam is produced from the boilers. High temperature, high pressure steam, and it is used for the process, refining process. Balance steam is used for the power generation. The balanced steam is utilized for rotating the steam turbine. From there, we can generate the electricity. It's called cogeneration plant. In any, not only refinery, in any process industries, a sugar plant or a steel plant the excess heat, the heat can be converted to the useful energy like electricity. So here we are the heat is converted into that steam, excess steam is converted into the electricity through steam turbine. So this power plant is called a cogeneration plant. Then process instrumentation control. So in any equipment, in refineries, all the processes are in a closed condition. So we cannot see in a naked eye. So pressure, high pressure steam, high temperature. And since petroleum products are hazardous in nature, so it is all the processes are happening in the closed vessels and pipelines. So process instrumentations, it is a very important in any refinery. So from there only we could able to know what is the pressure, what is the temperature, what is the flow of various products. Then heat exchangers and cooling towers. So it is also very important in a refinery, in a distillation unit. So all the separation processes are taking place near high temperature, high pressure. Then pumps and compressors. So pumps for pumping the products, pumping the diesel, petrol, then water, processed water. The compressors are used for the, again, this air compressors. So in any petroleum industries, air is the very important energy, because it is there is no harm in the energy. So instead of electrical, most of the places we are using the pneumatic instrumentations, pneumatic valves, pneumatic control valves, and so on. Then pipelines and control valves. So pipelines is all the refined products are taken to the storage tanks. So refinery is a huge area, so hundreds of acres. So the pipeline is very important to transferring the petroleum products, whether it is inside or outside the refineries. Then water treatment plant. So what is process? What is very important? So it's very important equipment. Then large product storage tanks. The thousands of KLs capacity. We are installed in a refinery, hundreds of tanks, right from the crude oil, then finished product like petrol, diesel, naphtha, kerosene, ATF. So separate tanks are installed for the storage. So what is the role of engineers in refineries? So engineering construction or any extension in the existing refinery. So civil engineers, structural engineers, so very much required for the refineries. Then operation, production. So chemical engineers, petroleum in a petroleum refineries. So major operation is the chemical operation only. So chemical engineers are involved in a production, operation and production units. Then maintenance. So maintenance, mechanical engineers, electrical engineers, and electronics engineers. Then boiler house, boiler operation and maintenance. Then power plant operation and maintenance. Process instrumentation and maintenance. Fire and safety. So fire engineers, mechanical engineers, electrical engineers can be involved. Then innovation and energy efficiency. See, these are all the rules work involved in a refinery. Then to determine the requirement of manpower and material and equipments, arranging production schedules according to the needs of marketing demand. So based on the demand in the market, so they have to plan in such a way. So which product is more? Arranging various input at right time and in high quality to ensure maximum utilization of all resources, to maintain optimum level of inventory, to maintain flexibility in manufacturing operations, coordinate between labor and machines and various supporting departments. See, these are all the roles, various roles of engineers. So whether it is chemical engineer, whether it is mechanical engineer, electrical engineers. So these are all the various roles in the refineries. So what are all the opportunities and challenges? Implementation of innovation and modification of the system in the refinery area is very difficult as it is coming under the hazardous area classifications and it is going through as per the regulations and standards. So it is not a ordinary industry. So we have to follow the certain standard operating procedure. So right from the main entrance, so we have to follow the safety standards, safety rules. Any other changes in the layout or system, it has to go to the Pollution Control Board and the Environmental Ministry for approvals. All work shall be approved by the OSD and PESO standards. All the works are carried out as per the SOP, standard operating procedure. The standards followed by the hazardous industries like the refineries, all the oil industries. See, they have to, even it is the project stage or operation stage. So we have to strictly follow the standards. So in India, we are following the Oil Industry Safety Directorate, then BESO standards. So first we have to, so engineering department should prepare the layout drawing before the what work they are going to carry out. Then we have to send to the our own engineering department for approval. Then it goes to the Pollution Control Board, and then it goes to the PESO. So after that, only we have to start the any major change work. Major change. There is, if you want to commission any generator or a motor, any equipment or compressor, air compressors or pumps. So all the engineers having the opportunity of opportunities to work in a refineries. Innovation in refineries. So waste heat recovery in all the heat exchangers, recycling of waste stream from the process and power plant, VFD system provision for the air compressors and cooling towers to achieve the energy conservation. So variable frequency drives. So we have to provide this power electronic device for a motor to drive the mechanical device like air compressors or pumps, cooling tower motors, and so on. So VFD provision for all larger capacity pumps. So instead of conventional starter, so we are providing the variable frequency drives, all the motors, AC motors. Planning for installation of renewable energy like solar power, wind power. Optical sensors for pressure, temperature, level and flow measurements controllers. So it is, these sensors are coming under the instrumentation and control. So in a, if the refinery is old refinery, so engineer can focus their innovative ideas. These are all the innovative ideas. So instead of conventional pressure controller, we can introduce the optical sensor to measure and control the pressure of the products and temperatures, level and flow measurements controllers. So level and flow measurements we can install in the storage tanks and the pipelines. Then IoT based control and monitoring. So we'll in a later slide we can discuss about the IoT based monitoring system. So these are all the challenges for the engineers. Existing refinery, the engineers can focus their innovative ideas to install this VFD system and optical sensors for the instrumentation system. So again, this is one of the comprehensive layout for refineries. So we could see the exploration, refineries, storage, and transporting through the rails and trucks. So these are the Azoras area location, terminal storage location, and logistic transportation of the petroleum products. So you could see the both road transport as well as the railways through rail wagons. Electrical system misuse. So in any hazardous industries, there is electrical system is one of the critical issue. So we have to focus in a separate standard. So safety, continuous operation and sustainability, total project cost reduction, corrosive and harsh environment protection, hazardous location protection, grounding and bonding, power quality, efficiency and reliability, extreme temperature protection, liquid ingress protection. See, these are the electrical engineers who focus these areas. These are the very critical area in any hazardous oil industries. whether it is refineries or oil storage terminals or LPG bottling plant or LNG plant, storage plant, and so on. It is based on the standards. So every equipment having a separate standards. You take generator, there is a separate standard. Then LPG bottling plant, there is a separate OSD standard. Then refineries, the refineries, various areas classifications. Refinery tank farms. So as I discussed with all the refined products is stored in a larger tanks. So that area is called a tank farm. So you could see the storage area. A key benefit of a tank farm automation in a refinery is to improve the operational flexibility, which provides safe operation with the many operational constraints. The ability to accommodate a low-cost crude purchase or deliver a finished product within a specific time provides financial benefits to both refineries operation and to supply chain management. As these enterprises systems become more digitalized, it is essential that the tank farm automation integrates well within them. So the tank farm are used for storing the crude oil as well as the finished product. Then pipeline to tank farms. The tank farm must be environmentally safe, and it is important to plan feasible movements like piping and execute the movement without delay or risk of product contaminations. The best practices, the topology of the piping system is precisely known and built into the tank farm automation system. The status of the piping system, the block valves, the control valves, and all pumps must be known. Planning must take into the consideration any leaking valves, defective pumps, as well as other simultaneous material movements that could conflict with the lineup path of the other movements. The management for piping paths effectively books or reserves pumps, valves, and piping segments for the duration of the movement. Planning a series of product movements can result in a many feasible solutions with many simultaneous movement paths. So this is the planning, how to plan the pumps and pipelines and tanks. Since so many petroleum products are involved, so we have to prepare a separate planning for the pumping the products to the tank. Product tank filling. The selection of particular pumps, flow meters, valves, and pipe segments place limits on the flow rates for feasible pipeline paths. This can be a critical decision that impact the duration of the movement. For example, a blending operation involves lining of multiple rundown tanks to a blunt header that flows into the product storage tank. The selection of a small pump or a small flow meter for the alkylate blending components might limit the blend rate and extend the time required to fill the product tanks. This could impact future oil movements by tying up the needed equipments. See, again, this is how to allocate the pump to pumping the products, petroleum products to the particular tank. See, again, this is the challenge for the operation engineers. If there is any small mistake also, it will be mixed with the other product. it will land up with the complicated problems. So not only the mixing of products, the characteristics of the product itself will vary, and it will end up with the dangerous problem. For example, if you use the pipeline both kerosene and MS, then it will be you have to take the precautionary measures before the pumping the products. Otherwise, the MS will mix with the kerosene, then the application it will be create an accident, fire accident. The people may thinking that it is a kerosene, but it will small quantity of MS mixed with the kerosene. So we have to take the precautionary measures during the pipeline operations, pipeline transfers. So it's a very critical problem. It's very challenging to the engineers. So what is IoT implementation? So in any old refineries, so we can implement the IoT, Internet of Things. It's called Internet of Things. So we have to lay the data cables. Then we have to replace the valves, control valves with the motorized valves with the sensors. So these are the schematic for the automation of the oil industry. What is IoT? So Internet of Things is the network of physical objects, devices embedded with the electronics, software, sensors, and a network connectivity, which enables the objects to collect and exchange data in a refinery. IoT allows objects to be sensed and control the refining process from crude oil to the LPG, petrol, HSD, ATF, FO, etc. remotely across existing network infrastructure, creating opportunities for more direct integration between the physical world and computer-based system, and resulting in improving efficiency, accuracy, and cost benefits. So this is the advantages. If you implemented IoT in a refinery, these are all the advantages. Measuring parameters: pressure measurement, density and viscosity measurements, flow measurement, liquid analysis, corrosion and erosion monitoring, gas analysis, level measurement, flame and gas detection, temperature measurement, tank aging system, industrial wireless technology, safety measurements. So these are all the measurements we are used in the refineries. So by implementing IoT, we are replacing the conventional pressure gauge. This is for pressure measurement, and also density measurement, flow meters, gas analyzers, level measurement, it's level gauges, servo gauge. It is measuring the level in a level of products in a storage tanks. Then industrial wireless technology. So using the wireless technology, we can integrate all the instrument in a control system, control panels. So Internet of Things could be used in a refinery to monitor critical parameters like product pipeline thickness, flow rates, pipe pressure, and so on. If these areas are accessible to human person, a lot of measurements are typically logged by the hand. But logging this amount of information by hand is a time-consuming job and fairly costly for the company. Keep in mind that some areas of a refinery need to be measured in exact real time, for instance. A value that needs to be controlled based on flow rates being monitored elsewhere. In that case, a change in a flow rate would require almost instantaneous control of a valve. That's what. So in a refinery, there are a lot of products. More than 10, 15 products are involved. So measurement, taking measurement is a very difficult job. By implementing the IoT, it could be simplify the process. IoT does allow for seeding more points for the more accurate data. For example, many aspects of a refinery are engineered with the specific levels of uncertainty because they simply cannot be measured. Also, a particular part of the refinery may not be able to run at the same pressure as it would get more reading points are available. To solve that problem, the IoT devices could provide a greater insight and extra data about the flow, allowing the refinery to run at higher capacity. The IoT network would also save the refinery costs by limiting the personnel needed to the manually monitor or the amount of equipment that requires wired communication. So these are all the advantages of IoT devices. So pipelines leakages. One of the primary concern with the oil and gas pipelines is leakage and the financial, environmental, and reputational damage it could cause. If methane gas is released without being burned, it has bound for bound and 25 times the impact on climate change than carbon dioxide. There is also a high explosion risk for the gas leak when it is exposed to the atmospheric pressure. And oil does not hold a risk of explosion. There are major risks associated with the pipeline leaks. So not only methane, all any gas, like LNG or LPG, so it will expose to the air. It will convert 25 times. LPG is 250 times in volume. So it will the accident fire explosion able to spread to the entire refinery. Even it could spread to the nearby human living areas. So pipeline leakage is very dangerous. So it could be identified before it happens. That's why you are periodically they're testing the pipelines and thickness, pressure test and all. So these are all the major challenges of engineers employed in a refinery. So they have to closely monitor the data of your pipeline areas, not only pipelines, the storage tank also. So that is as per the standard. So cleaning of storage tank and also painting of storage tanks and all, it is framed in the standards. So as per the standards, they periodically they have to do the maintenance whether it is testing of testing or cleaning or painting. It is very, very critical. It's very, very important. So the IoT can also help monitoring the pipeline components like pumps and filters. Without a smart system, a company would have to send someone to perform periodic routine maintenance every 3 months, for example. But with the extra data of a company would gather from its IoT system, it may be able to wait for the maintenance and pump and filters replacement until the performance of the system starts to decline. Through some amount of preventive maintenance will prudently still be performed. So as I told, there is a system standard. As per the system, we have to monitor the data of the all equipments, not only the pipeline, tanks, and also the all utility equipments like motors, compressors, pumps, cooling towers, heat exchangers like condensers. If you go to the power plant, so you have to see the turbines, alternators, then allied electrical equipments like transformers and switch gears. So each and every equipment has the should have the data and also connected the periodical maintenance. So these are all the engineers role of engineers. So whether it is mechanical engineer, electrical engineer, electronics engineer, instrumentation engineer, chemical engineer, fire engineers. See, every engineers attached to the departments. Electrical department, power house, boiler house, then facility, utility departments, compressors. So all engineers should know their roles and responsibilities. So oil and gas industries is still evolving when it comes to realize the full value of IoT. It has yet to revolutionize the oil and gas like it has other industries. However, the IoT is making it a lot of benefits for companies to collect vital information, which has led to more informed business decisions. Connected wireless technology is helping the oil and gas industries optimize for efficient pumping activities, maintain the pipelines and tank form, monitor equipment failures and gas leaks, monitor pipe thickness, temperatures, and erosion in a refinery. So this is the, as I already discussed, it's very, very important. It is possible only if you implement IoT implementation only. So what are all the technological challenges? At present, IoT is faced with many challenges such as scalability, technological standardization, interoperability, software complexity, data volumes and interpretation, power supply, interaction and short range of communication, wireless communications, fault tolerance. So as already discussed, no. So any refinery, it comes under the hazardous industry. So each and every equipment, so we have to, when we are designing, we have to choose accordingly as per the standards. So even wireless communication also, we have to check, we have to go as per the hazardous standards. So we can also aware that during even petrol pumps, we should not use the mobile phones inside the retail outlets, because in the inside the retail outlets there is a petroleum vapors always will be there. so that electromagnetic waves could create the fire accident in the petrol outlets. So we should not use the mobile phone inside the petrol pumps. So next, petroleum product terminals. This also is coming under the oil industries. So after refining the products through pipelines, the products are transported to the major terminals in a state or a district. So as per our requirement. So these are the storage storage tanks, yeah, terminals. So in Chennai, you could see the Andarpet, Porkupet, force terminal inside the harbor. So these are all the major storage terminal in Chennai. The same way, various districts in the Tamil Nadu, Trichy, Coimbatore, Madurai, Tirunelveli, Thoothukudi. So there also we have the major terminals, storage point. So these storage tanks are filled by the pipelines running through Chennai to Madurai. So storage tanks and auxiliary equipments, the instrumentation are expensive asset that provides such volume for the transition of batch crude oil, the ships, and a batch finished product shipments while the refinery operates continuously for years at a time. In contrast to large refineries tank farms, there are many similar truck loading terminals that are involved with oil movement and storage operations. These terminals typically receive gasoline from refineries via pipelines and add ethanol to the meet reformulated gasoline requirements. Digital transformation of tank farm automation for oil movements and storage builds on a legacy of established best practices. It is essential that digital automation applied to oil movement and storage be compatible with the important refineries and terminal infrastructures and be compatible with the various software packages and stakeholders throughout the operations. In your company also, out of major terminals are automated. The existing conventional flow meters. So we have removed the conventional flow meter. We provided the electronic meters, and also some of the terminals are automated. Right from for example, if a truck want to load diesel in a terminal, right from the main gate, it will use the access card. See, if the particular driver access their card only, it will be allowed, the truck will be allowed to the terminal. Then it will be allocated to the bay. Suppose bay 2 means they should go to the bay 2 and it will show the access card. That only that the flow meter valve will open. We can able to fill the products. So this is called automation of terminals. So this what is the various types of tank gauging system. So tank engine operations, radar, microwave, autostatic, and capacitance, ultrasonic. So these are all the various type of tank gauging system. So it is very important for the terminals. So each and every day they have to record the quantity of products. Tank farm operators execute the movement that involve refinery tanks, pipelines, barges, trucks, rail cars, etc. So every facility will have specific physical equipments, instrumentation, control system, planning and tank farm software, and operating procedures. Training of all stakeholders to work cooperatively with a clear understanding of rules and responsibilities is an essential best practice. The exact instrumentation, automation, operating procedures, plant operating softwares, and business applications will vary. So this is the again. See, as I told you, transportation of products. One is pipeline. Number two is rail wagons. Number three is trucks. Through transport through the roads. As far as safety is concerned, pipeline transportation is the safest one. So laying a pipeline is a very high cost expenditure. So other two modes are utilized. See, based on the requirement. So next is LPG bottling plant. See, this is also one of the oil industry coming under the oil industry. So this is the various type of cylinders we are used for the bottling purpose. So whether it is domestic or commercial or industries, see various type of cylinders and various quantities are followed in our country. For example, if you take a domestic, oil companies, government oil companies are giving 14.2 cylinders. Then 5 kg cylinders. This is for domestic usage. If you take commercial cylinders, 19 kg cylinders. This is for commercial. Then industries, 47.5 kg. Then 425 kg. These capacities are coming under the industrial applications. So this is the standard we are following in India. So what is the LPG bottling plant operations? So bulk LPG unloading shed. These are all the various locations in a LPG bottling plant. In LPG storage vessels, LPG pipeline manifold, LPG compressors, LPG pumps, cylinder filling system, check scale, valve leak testing, cylinder body leak testing, quality check. So in any LPG bottling plant, there is a storage vessel. The storage vessel is filled by the LPG through tank trucks or pipeline. See, that is depends upon the location. If we take Chennai, that in Chennai plant is filled by the pipeline receipts. Other than Chennai plants, places, other like Pondicherry, Trichy, Madurai, and tank trucks, by way of tank trucks, the LPG, bulk LPG is transported to the plant. So that LPG is stored in a storage vessels through LPG pumps, LPG compressors. The LPG is bottled in a cylinders through the filling machines, and it is sent to the market. This is the various operations of the LPG bottling plant. This is the pictorial way of a bottling plant. The cylindrical tanks are storage LPG storage tank. The other shed, the nearby place is the filling shed. Mr. Google. Hello.
Go.
Mr. Nagarajan, sir.
Yeah. Tell me.
Sir, can I play one video?
Yeah. No problem.
Okay. Thank you, sir.
Sir, Pandian sir.
Yes.
Yes, sir.
I'm going to play one video.
Okay, sir.
You able to see?
Yes, sir. We
Hello?
can see, sir. Yeah, we can see, sir.
Okay. This is the one video of LPG bottling plant. Is Google able to see
Yeah,
Yes,
it is, yeah.
LPG plant?
yeah.
What about the audio?
Audio is not not able to hear, sir. Audio is not proper.
This is one LPG plant, video of one LPG plant. The LPG cylinders, empty cylinders are pushed to the conveyor. It is going to the filling machine for LPG filling. This is the filling machine, LPG filling machine. This is called carousel, electronic carousel.
Rosa.
So based on the various brand manufacturers, it can be available 24 machine, 12 machines, and 72 machines.
That is per carousel.
This is for carousel, number of machines. It's called carousel.
Yeah, from 12 cylinders to 72 cylinders capacity.
Yes, sir, yes, sir, yes, sir. See, based on our requirement.
Uh,
This is an automatic plant actually. So after that, it goes to the check scale for checking the weight. Then it goes to the wall test for leak test. This is called check scale. Wall test. Sealing. After filling, after a leak test, it goes to the sealing machine and it goes to the market through trucks. So filled cylinders are handled by the loading, unloading by the forklifts. But in our plant, through manpower, some of the plant through manpower only we are doing. So this is the higher industrial cylinders. 47.5 kg cylinders. This type of huge cylinders used for the industries. Is it all able to see?
Yeah, the plant.
Yes, sir. Yes, sir. So video is over.
PGA bottling plant, correct.
Yes, sir. So this is the storage vessel of LPG storage vessel. So some plant will have the bullets, some plant will have the spears. So depends upon the storage capacity, it will vary. See, the white pipelines are product lines. Red color lines are fire retardant lines, fire protection lines. So this is the LPG pump house near the storage area. There will be a pump house and compressor, LPG compressors. They pumping the LPG liquids to the filling shed. The compressor is used for the making the pressure difference, positive pressure. So in any LPG tank, it has the 80% of liquid LPG and 20% will be the vapor. So this is the filling operation. So LPG, liquid LPG is pumped through the LPG pumps and it goes to the filling shed and filling machines. So input is the cylinders, water, LPG. The empty cylinders are as you seen in the video. The empty cylinder is unloading to the conveyor. The cylinders first goes to the through the chain conveyor, goes to the washing machine. So this is a washing unit where the water is sprayed on the cylinders to remove the foreign materials. So otherwise, the tar weight will be varying. So accordingly, there will be the uneven filling of LPG. So sometimes it will be underweight, sometimes it will be the more weight. Since LPG is the hazardous material, it is not acceptable for the overfilling and the underfilling. Mainly overfilling. So overfilling means there is while transportation, there is a chances of leakage. It create a fire accident. So as far as tire weight concerned, it is weighed by the electronic scale for weight accuracy. So next, it goes to the air dryer. So after drying, after washing, it goes to the dryer unit for drying the moisture, water particle. The drying unit is an online equipment used to dry the cylinders coming out of a washing unit by blowing the air on the sides and top surface of the cylinders as they move. So this is the filling machine. As you seen in the video, it is the electronic filling machine. It's a 24 machine. So each machine having the electronic scale and controller and a flow meter, LPG flow meter. Each machine will consist of these electronic devices. So the machine's LPG is filled in a cross weight method. So tar weight of the cylinder plus 14.2. So once it enters, it will take the tar weight plus 14.2 kg of cylinders. After filling the LPG in a carousel, it comes out and first it goes to the check scale. The digital check scale weighing system segregation unit is designed to check the cross weight of the filled LPG cylinder and reject the cylinder from mainstream onto a loop conveyor if the cross weight is more or less than the stipulated value. So we are giving the tolerance plus or minus 50 gram. If the cylinder weight is more than 50 grams plus, either way, plus or minus, it is rejected to the separate line for correcting the weight. If it is okay within the plus or minus 50 grams, then it goes to the next stage for valve leak detector. The electronic check scale is programmed in such a way to subtract 14.2 kg or 19 kg from total weight of the cylinder, and the tare weight will be displayed. Operator has to compare the displayed tare weight value with the tare weight value punched on the cylinder, and if the value is beyond the permissible limit, the cylinder will be rejected. Then after testing the cylinder, it goes to the water bath for the body leak. This is the picture of the water tank. See, online this thing, while moving the conveyor, it goes to the tank and it will come out. If there is any leak, body cylinder leak is noticed, then it will be removed from the conveyor. Next for evacuation stage, the full LPG is evacuated and it will go for further repair of cylinders. This is the weight correction unit. As I told, the sex scale is rejected, then it goes for the weight correction. If it is excess, the excess weight will be evacuated from the cylinder, and again it goes for the correcting the weight. The unit is an online equipment used to ensure the correct weight of LPG fuel is carried in the cylinders. Underfilled cylinders are filled with additional quantity of LPG and the weight is corrected. Overfilled cylinders are checked and the weight of this LPG fuel is corrected by the evacuation process. So this is the next stage of any unfilled, overfilled LPG cylinders. So normally it may not be happen because it is we are using the electronic scales, the electronic filling system. It is very less. So unless the cylinder tare weight is wrongly punched, it will not happen. This is the valve change. See, as I told, after check scale it goes to the valve test. If the valve test, if there is any leakage in the valve, then it goes to the other conveyor, transfer to other conveyor for new valve change. So before that, entire LPG will be evacuated, and then it goes for valve change. So this is the valve change system. It's another system is valve change without evacuation. So there is a new system we have identified and we are implementing. So this is called telescopic conveyor. So you could see the truck. For truck loading, we are using the special type of conveyor, telescopic conveyor. This conveyor, it goes to the truck for loading the filled cylinders. So without human intervention, the telescopic conveyor goes to the inside the truck for loading it goes to the market. So before that, before dispatching to the cylinders, we are doing the quality check. So each and every batches we are taking the 20 cylinders from the conveyor and we have to check whether the weight is correct and leak free valves. So we have to ensure the quality of cylinders and also the safety of the cylinders. So as I told you, LPG is the hazardous material. So we have to take precautionary measures before dispatching the filled cylinder to the market. So one is weight correction, another one is leak test, valve leak test, then cylinder body test in the water bath. Then we'll check the proper sealing. So this is the, so some of the plant we have the manually through telescopic conveyor we are loading the truck. So some of the plant we are using the forklifts for transporting the loading, unloading the cylinder from the trucks. So we could see the cylinder yards in the LPG bottling plant. So here also we are maintaining the safety regulations, standard operating procedure from the entrance main gate. So all the employees, operators are given the SOPs based on their allocation, work allocation. If they are in the pump, LPG pump house, there is a separate SOP. Then storage area, then filling shed, then loading, unloading of bulk LPGs. Thank you very much. So Google. Nagarajan.
Yeah, thank you, Mr. Pandian. It was a very nice and informative lecture. I think a lot of visuals also you have shown. And you have explained the challenges to the young engineers. What are the opportunities and challenges available in oil refinery and various departments, how they function, what are their work procedures, etc. It was really very nice, and thank you for the informative lecture, sir. Thank you very much.
Thank you, sir. Thank you.
Yes,
Thank
sir.
you all participants.
So thank you so much, sir. I think we are opening up for QA session. Anybody have any QA? I think you can unmute, or even you can put it in chat box for any QA question and answer session. And Pandian sir, thank you so much, sir. I think you are patiently.
Thank you, sir. Thank you, Google sir. Thank you, Google sir.
Yeah, most of the students are chemical engineering, especially final years. So
Yes,
they would definitely like the information what you are given.
Yes.
I think one question has come from Muthu Mayal, sir. Sir, what are the major problems faced by the production engineers and operators working in crude processing constantly? Can you give some examples of such accident that occurred in refinery and the rectification method used to avoid that in future?
No idea in refineries. No idea.
Okay. But in the production engineers, like anything like you faced any major problems, sir?
No. Actually, in hazardous area, so they have to strictly follow the SOPs. I don't know. Remember the exact issues, but there is no incident.
Yeah. Since IOCL and every
because
plant
because of this modernization or this thing and all, it's very
yeah, rare unsafe conditions.
rare chances, rare incidents.
Yeah, and will the demand of crude oil products come down due to EVs?
And all is government jobs.
Due to electric vehicle, he is asking, sir.
Electrical vehicle.
Yeah. Okay. Then no, it will take another 10 years. As far as our India is concerned, 2030 only it will start.
It will slowly phase out the petrol vehicles.
Yes, sir.
First of all, a lot of infrastructure is required. They have to provide, like petrol pumps, they should have charging stations.
Yes, sir. Yes, sir. So, see, one more thing is there, sir. So now we are using petrol, diesel. So, if you switch over to electric vehicle, then it will be equally. We have electricity, na, sir.
Yeah. Electric power you
Yeah.
have to get.
Yeah. Unless you are switch over.
Electricity also you are burning fossil fuel only you get the
Yes, yes,
electricity.
yes, sir. Yes, sir. That's why. Unless otherwise you are switch over to renewable energy like solar, wind, then it will be there.
Only advantage is the air pollution will come down.
Yes, sir.
Air
Yes.
pollution will come down.
Sir, another question come from Arun. Sir, can you please share your thought with us when you entered the oil industry, and which one give a more challenging to you, sir?
Yes, sir. I joined Indian Oil in 1985. So now I am going to complete 35 years of experience. So I have worked in various locations, sir. In our office and LPG bottling plant. So LPG bottling plant experience is very challenging and critical experience. So in my last 5 years, I have done the lot of work in LPG bottling plant in Pondicherry. So I have done the renovation of upgradation of electrical substation, then commissioning of generators, commissioning of compressors, air compressors, commissioning of LPG compressors, LPG pumps, and so on. A lot of works is for the petroleum and the oil industry is it's very challenging industry for the particularly engineers. All, if you take chemical engineers, mechanical engineers, electrical engineers, instrumentation, electronics, and so on. So a lot of opportunities are there in oil industries, particularly chemical engineers.
Yes,
I would
sir.
say all engineers. As I told you now, all what are the roles and challenges of engineers. So like this, lot of opportunities are there.
Okay, sir. Thank you, sir.
This is my experience.
Yeah.
Yeah.
Yes, sir. Yes. We have one more from Bobin. You have shown LPG industry video. In one of the gas leaked from that, what will be the first step will be taken by the workers at working there?
See, in any oil industry, there is a sufficient safety protection system is there. In LPG plant, there are gas monitoring system, sprinkler system, fire hydrant line. See, for example, if there is any leak, LPG leak, it will reach the explosion limit, and automatically that fire alarm will indicate. And simultaneously, there is a sprinkler, water sprinkler. It will open automatically. It will safeguard the situation.
Okay. There is another question from Magesh. So crude oil consumption is hazard to environment, but we do that. Is any safety measures to control air pollution?
No, as far as refinery is concerned, every products are confined within the tank and the pipeline only. See, the leakage is very small. In my opinion, it will not affect much.
Yeah. And Tamil Selvan has asked one question, sir. Is the oil industry recruit young engineers, and what qualification we need?
See, normally all government refinery companies, oil companies like IOC, BPC, HPC, and all, they are recruiting through the GATE score. GATE, see, any engineer should undergo the GATE exam, qualify, and they can attend based on the advertisement. Every year, it will be advertisement will be coming in newspaper and other medias. So accordingly, they have to.
Maybe
yes.
mostly application is online nowadays.
Yes, sir. Yes, sir. Everything online only.
But a very important thing is, as you told, I'm also telling students wherever I go that to get into public sector companies, you have to qualify the GATE exam. So
yes, sir. Yes, sir. Yes, sir.
That is more important.
Yes, sir. There are three step is there. One first is GATE, then next one is group discussion, third is interview.
Okay.
Yes,
So
sir.
opportunities are there, lot.
Yeah. Thank you, sir. And we have a last question. I think we'll close up with that. From Naveen. Sir, in the video you showed, we saw heavy oil and naphtha broken into single chain compound. What are they and what are their uses?
So no idea, because I have the LPG plant experience.
Yes.
For awareness, I have done this thing, that video and all.
Yeah.
So focus, they should have all students should have the exposure in oil industry. For the purpose only, I have played the video.
Sure, sir. Sure. Yes, sir. With this, I think we'll come to the conclusion. Can I ask our Nagarajan sir to give some concluding remarks? So after that, we'll have vote of thanks, sir.
Okay, thank you, Google. I really thank Dr. Pandian for giving this informative lecture, which has given a very good insight into the oil refinery operations. And one question was there, which I think it was escaped Google side. Somebody asked, you get oil, gas and water from the earth. Oil and gas are utilized. What do you do with water? Actually, water is in the upstream itself. Onshore, offshore location itself, the water is separated in the three-phase separator, and the water is treated because it may carry minute amounts of oil, traces of oil. So there are equipment to remove the traces of oil, and the water is discarded, or in some locations they use this water as injection water. So when the reservoir depletes, the pressure comes down, the oil will not flow on its own. Then we have to force the oil to come out. So we inject water or gas, whatever is available. So the water removed, separated from the well fluid, can be, if it is in good quantities, can be used for water injection. Or otherwise, after removing the traces of oil, it is just discarded. That's all. So that the main content and the operating experience you have shared, and I think students have got very good understanding of the field now, and there are good opportunities. And also you have explained what are the stages in clearing the recruitment process. Means first is gate clearance. After getting good scores in gate, then you have to go for group discussion. I think the written test step is not there nowadays, because gate qualification.
Yes, sir. Yes, sir. Yes, sir.
Yeah, gate qualification is considered as a written test.
Yes, yes, sir.
And group discussion is one important thing that requires a lot of communication skills. Our young engineers should keep abreast with the developments, and they should read the newspapers and all. They should watch news channels, and that habit has to be developed by the students, because in the group discussions they may throw one topic of today's topic. You must have seen that topic in the newspaper in the morning. That topic will be thrown to the group of people, and they will watch how they discuss, how you discuss on the topic. Okay, so that means you need some kind of general knowledge and keeping abreast with the developments that are happening around you. Okay, maybe like today there was one interesting question, electrical vehicles. Maybe that can be a debate point. So when electrical vehicles come, how it will impact the oil industry. So that can be a discussion point, and it will be thrown to the group of people. So that way, people also should develop the communication skills and argument capabilities. And you should project your views very politely and at the same time firmly, so that so it is only how you project yourself in the group discussion and how strongly you put forth your points. So I think that is one important thing, and keep studying. Keep internet is giving you a lot of information, so you can go ahead and keep searching for the information and all. And you are still in the final year, means you have to now itself you have to search for various job websites and keep understanding the requirements and keep qualifying yourselves further. Okay, academic qualification is one, plus other qualifications like these are also very important. So that is my piece of advice. So thank you, Dr. Pandian, and let us hope
Yes,
to
sir.
have a good session. So thank you so much, and
Yes, sir.
Gokul, over to you.
Thank
Yes,
you,
sir.
sir. Thank you, sir. Thank you. Thank you very much.
Thank
So
you so
mainly
much.
that GDGD is
Yeah.
communication skill. To test the
Yeah,
communication skill,
communication.
then decision making, then leadership qualities.
Qualities, correct.
These are the main. Okay, sir. Thank you, sir. Thank you.
Thank you,
Yes,
thank
sir.
you so much.
Yeah. So thank you so much for our Nagarajan sir as well as Pandian sir. I think this is IICG. We're conducting this is the webinar 05. So almost last 4 weeks of October we have conducted, and the first week of November, I think before the Diwali, we are conducting this event. So once again, I thank our Pandian sir who could able to spend us almost some 2 hours, I think, in the afternoon of Saturday. So definitely, I think even he's more than age of 50. The passion towards students is almost there. So that is what we need to learn from all of us. Thank you so much, sir. I also thank our Sriram Engineering College management who could able to support from their side to organize this webinar. Can I invite our Soumya, assistant professor, to deliver vote of thanks, ma'am? Soumya, madam, is there?
Yes,
Or,
sir.
Suman?
She's there. Just a minute, sir.
Yeah, please.
Good evening to one and all present. It's my privilege to propose the vote of thanks on this special occasion. First of all, I thank Dr. S. Kannan, Principals of Chemical Engineering, who has encouraged to conduct this online webinar. I thank Dr. L. Nagarajan, the Head of Department, Chemical Engineering, SREC, and Mr. D. Gokul, Honorary Secretary, Indian Institute of Chemical Engineering, Chennai Regional Center, and Dr. S. Sivamani, Assistant Professor, Chemical Engineering Department, SREC, who has coordinated this wonderful webinar. A big thank to our chief guest, Dr. G. Pandian, Senior Manager, IOCL Chennai, for his effort towards opportunities and challenges of engineers in oil industry. We are all inspired by your great words, sir, and this will surely make us to move towards our brightful future. Finally, I thank all the faculty members and the students for their involvement and their willingness to participate in this event. Once again, I want to state that we are all most grateful to all speakers on this webinar. We thank you for being with us this evening, sir. It has been a great pleasure.